Hi everyone. The goal of this video is to learn all about matrices and matrix operations. To begin, we're going to talk about what a matrix is. And my definition is it's an organized set of numbers. But if you Google what a matrix is, they might be a little bit more specific. And Google might say it's a rectangular, in the shape of a rectangle, array of numbers. Well, they say numbers, symbols, or expressions, so we might also add in like it can be equations or symbols, especially if we're trying to solve for something. Arranged in rows and columns, which makes sense because in order to make it rectangular, it'd have to have rows and columns. So below are some examples of matrices. These specific matrices are in a context. They don't always have to be, but these are. And the first one's in a baseball context. So this is a way to organize baseball results. And we're talking about baseball results from some April and some May. So we're talking about Cubs, Sox, and Cardinals, and we're talking about wins and losses. So columns are wins and losses, and rows are Cubs, Sox, Cardinals. Okay, so it's really nice to use a matrix to organize information because it gives you a distinct categorization. It's kind of like, setting up a systems of equations, right? So I had x, y, and z, and then I had equation 1, equation 2, and equation 3. I could enter that data in a matrix format. Oh, and I guess I don't really have x, y, and z. I also have like the constant number, right? So thinking about Gaussian elimination, those were matrices we were using. Anywho, these matrices are the results from April and May. What I want you to do is I'm going to pause the video, and I want you to find the standings, total number of wins and losses, at the end of May for each team. And I want you to organize this into a matrix. So I'm looking for the total at the end of May of wins and losses for each team, organized in the matrix. Pause the video, go ahead and do that. Okay, so if you got the total, your matrix should look something like this. So our columns are wins and losses again. My rows are Cubs, Sox, and Cardinals. My wins are just a combination. So the Cubs won 12 in April and 15 in May, so they won a total of 27. Whereas they lost 14 and 13, so that's a total of 27 losses. Okay, so all you have to do is add the corresponding parts of the matrix, which each part of a matrix is called an entry. So an entry, T-R-Y, is just one spot in the matrix. It can be a number or it can be an expression. So just one number or expression, I'm just going to write number though, in the matrix. Okay. Now these stats might not be accurate because we all know Cubs are the best team, but that's totally besides the point right now. So this is how you would represent this particular data. And why did I make you do this? Well, this is exactly how you do matrix addition or matrix subtraction. In order to add or subtract matrices, all you're going to do is add or subtract each entry or each corresponding entry. So I'm going to write that down. To add or subtract matrices, all you have to do is add or subtract the corresponding entry. Pretty easy, right? So I added April wins and May wins. Those are corresponding entries because this one's in the top left and this is in the top left. Then I would enter the second row first column with the second row first column. I'd add or subtract those depending on what I was trying to do. Then I would do like second column, third row with the same spot over there, and I'd get my final matrix. Okay, so I like to do it in context so you have something to refer back to. Adding or subtracting a matrix is just like finding the wins and losses for a given amount of time for different baseball teams. Keep that in mind. Now, something to note is the order of these matrices. I'm going to write that vocab word down over here because there's not a spot. So the order of a matrix is just the dimensions of the matrix. Okay, so we always said a matrix is a rectangular array of numbers arranged in rows and columns. So the dimensions are just how many rows by how many columns. So we always write row by column. So for example, this is 1 row, 2 row, 3 rows by 1 column, 2 column. So these are both 3 by 2 matrices because we go row by column. And if you add two 3x2 matrices, you're going to result in a 3x2 matrix. What if I wanted to add a 3x2 matrix with like a 1x3 matrix though? So what if I wanted to add this matrix here, 12, 14, 15, 11, 13, 13, with a 1x3, which would mean there's one row and 3 columns. So 12, 10, and 13. Would I be able to add these two matrices together? And I know this is kind of a tangent here, but I'm just writing off to the side. The answer is no, because there are no corresponding entries. So like this one is in the first row, first column, and so is this one, but this one's in the second row, first column, and there's no second row here. So you can't add corresponding entries. So therefore you can't add matrices that do not have the same dimensions. I said that, but I didn't write it down. You should write that down in your own paper. Okay, here's another situation where we can organize our information in matrices. So at starts with S store, haha, funny, that's the name of the store. They only sell items starting with S, shoes, socks, and shirts. The matrices below show the information for the store. So one matrix shows the unit prices of the items they sell, and the other matrix shows how many were sold per month. So this one is the number sold, this one is the price they sell it at. Okay, so what I want you to do, and I'm going to pause the video, is I want you to take this information and I want you to calculate the profit made in both January and February. So like they sold 458 shoes in January, and each shoe they charged $48.50. So how much profit did they make on that? But they also sold socks and shirts. That's hard to say. Try that. So they made more profit than just on shoes. So I want you to calculate the total profit made in January and the total profit made in February, and I'll come back with the answer. Oh, and organize your information into a matrix when you're done. Okay, after a lot of work, I came up with the total profit for January and February, and I just added them together so you can see the total profit for the store in general. So to find the total profit for January, I had to take the number of shoes and multiply by how much each shoe cost, which gave me this number. But that's just how much I made on shoes. So I also do that for socks. So there were 560 socks sold at $5.75 a piece, so the store made that much on socks. Then same for shirts. There were 411 sold, 39 a piece. I made this much. If you add those all together, you get the profit for January. And repeat a similar process for February, and you will get the total profit made in February. So I could be like, hey, store, you made more in February. Let's go back and figure out what we can do to make as much as we made in January, right? Anyways, why am I asking you to do this? It's not because I want you to practice calculating profit, because I know you all know how to do that. But the reason I had you do this is because this is how you do matrix multiplication. So this outlines exactly what I just did, is how you multiply two matrices. And this is kind of a confusing process, so I like to introduce it with this context here. So to multiply two matrices, you're going to take the first entry of the first row and the first entry of the first column, multiply them, and then you're going to take the second entry of the first row and the second entry of the first column, multiply them, and then you're going to do the third entry of the first row and the third entry of the first column, multiply them, and add them together, and that'll give you your first entry. Okay, so this process is how you multiply two matrices. I'm going to give a more general example so you understand the process in detail. Just keep that in mind, though. Let's say you have all these different matrices, and I want you to do the following operations. Add them, add them, add them, but can you add them? You think about that on your own. Those are on your own problems. If I do tell you to do 3 times A minus 4 times B, I do want to note something that's kind of easy, so I'm not going to spend a ton of time talking about it. But if I'm having you do 3 times A, I'm having you multiply 3 by the whole matrix, which is just scaling the matrix by a factor of 3. So if you're going to scale the matrix, all the entries should get scaled. So 3A would just be 6. If I distribute that here, 3 times 3 is 9, but it's negative, so it's going to be negative 9. This would be 12, and 3 times 0 gives you 0. And this would be negative 15 and 3. So if I say 3 times A, I'm just asking you to multiply all the entries by 3. That's scalar multiplication. You're just multiplying by a number. Otherwise, what I do want to practice, because this is the harder part, is matrix multiplication. So like multiplying AB and BA and AC and CA and yada, yada, yada. Okay, so I'm going to start with, I don't know, I'm going to do C times, no, I'm going to do A times C. I don't know why, I just feel like it. So matrix A, and I'm going to have to keep scrolling here, but matrix A is 2, negative 3, 4, 0. And our last entry is worth -5. And, oops, I already forgot 1. And I want to multiply this by a matrix C. Matrix C then is 4, 3, -5. And -7, 2, 6. Okay, now to go through the process of multiplication, you are going to do the same thing like you did in the previous problem. The only difference is like there's more rows and columns here. Okay, so you always take the first row and multiply it with the first column. And you're going to add them. So if I'm doing the first entry of the first row, I'm going to multiply it with the first entry of the first column. So to find my first position, I'm going to do 2 times 4, which is 8. I'm going to add it to the second entry with the second entry. So -3 times -21, or excuse me, -3 times -7 will give me positive 21. So this is going to be the first entry of my matrix, which is 29. Now, if you're multiplying those together, this is the first row, first column. So 29 is going to go in the first row, first column. Okay, I'm going to try this first row, second column now. And the answer to this is going to go in the first row, second column. So you're going to do first entry with the first entry. So 2 times 3 gives me 6. Okay, and then I'm going to do second entry with second entry. -3 times 2 will give me -6, which will give me 0. And that's going to go in the first row, second column, because I multiplied the first row with the second column. It's just like if you're calculating profit. Okay, now let's do the first row with the third column. And this is going to go in first row, third column. So 2 times -5 gives me -10. -3 times 6 gives me -18. So that's going to be -28. Okay, so that's everything in the first row because I multiplied the first row with every column. So once I'm done with the first row, I'm going to want to go, drumroll, I'm going to want to go to the second row and multiply that with all 3 columns. So this will be second row, first column, so it'll go here. Okay, so 4 times 4 gives me 16, and you can even write this in here. And 0 times -7 gives me 0. So this entry here is just going to be 16. Okay, now I've done second row, first column. I'm going to do second row. Erase, come on. I'm going to do second row, second column. Okay, so 4 times 3 and 0 times 2. So 4 times 3 is 12. 0 times 2 is 0. So this is just going to be 12. Okay, now I'm going to do second row, third column. So it's going to go in the second row, third column. Okay, so 4 times -5 gives me -20. 0 times 6 will give me 0. So this is going to be -20. And I didn't leave myself enough room in the matrix, but I have to now do my third row with each column. So third row, first column, -5 and 4 gives me -20. 1 and -7 gives me -7. So it's going to be -27. Now I'll do third row, second column, and it'll go in the third row, second column. So -5 and 3 gives me -15. 1 and 2 gives me 2, so it'll be -13. Okay, now I do my last one. -5 and -5 is 25. 1 and 6 gives me 6, so that'll be -19. And that would be multiplying the 2 matrices together. Okay, so moral of the story, just keep it very linear. You go row by column, just like you write your order or your dimensions row by column. So first row, first column will be here. First row, second column will be here. Second row, second column will be in the second row, second column, so it'd be here. Makes kind of linear sense. So that's how you multiply matrices, and keep in mind that my resulting matrix here, oops, we're jumping all around here, that was crazy. Okay, my resulting matrix wound up being a 3 by 3 because there are 3 rows and 3 columns. But I started with a 3 by 2 and a 2 by 3. So why did it wind up being a 3 by 3? I want you to think about that. And not all matrices can be multiplied, just like not all matrices can be added. So on your own, I want you to try a couple of these on your own problems. Maybe do AB, CA, BA. I want you to see when matrix multiplication is possible and when it is not. Okay, you don't have to do all those, but do enough to come up with an answer. And then go ahead and answer these for me as well, and we will talk more about rules in class. Have a good night.